We're going to talk about Pythagorean theorem today, and Pythagorean theorem is the most remembered theorem in all of geometry. It is a squared plus b squared equals c squared. You might also see it as c squared equals a squared plus b squared. Those mean the exact same thing. Now a, b, and c are all lengths inside the triangle. So we have a and b are our legs. Now remember, we tell that sides are legs by the fact that they make the right angle. So this one here is a leg, and this one here is a leg. Another way to see that is the fact that they make an L. So they make that L, so they are legs. Then we have our third and longest side called the hypotenuse. Let me erase and start over on that. Okay, the hypotenuse is always our C value. Our A and B are always the legs, and it doesn't actually matter which one's A and which one is B. So we could say this one's A, this one is B, but then our hypotenuse is always C. So as we look at examples, we're going to try and solve for certain lengths in triangles. So in example 1, I want to find the value of x. I notice I have that right angle there, so I know I can use Pythagorean theorem. So first thing you need to realize is that you can use a squared plus b squared equals c squared, and then label in your picture which one is A, which one you're going to let be B, and which one you're going to let be C. So I'm going to let 3 be A, 7 be our B, and this is our hypotenuse because it's across from the right angle, and that's going to be our C. So now I'm going to start plugging those values in to our formula. Since we said our side A is over here, we have 3 squared plus our B value is 7, then we square it. Then C is x, and that's what we're trying to solve for, and we square it. So now I'm going to just work out this equation. So 3 squared is 9, 7 squared is 49, and x squared is still just x squared. Simplify 9 plus 49, which is 58, equals x squared. Now to undo a square, you have to square root. So square root both sides, and you get x equals the square root of 58. Remember, we're not going to use decimals, we're going to use exact answers. So the square root of 58 is my answer. Alright, now let's look at example 2. Find the value of x. Again, I know I have a right triangle, so I'm going to use a squared plus b squared equals c squared. Label your A, B, and C. Notice on this one, the L is the 6 and the x. So those are going to be my A and B. And then 6 square roots of 2 is going to be C. Now I'm going to plug this in. So I have 6 squared plus x squared equals 6 square roots of 2 squared. Now, before we go any further, I want to talk about how we square this term. So I'm going to add a page here. And I'm just going to work on 6 square roots of 2 squared. What that means is 6 square roots of 2 times 6 square roots of 2. So I know I have 6 times 6, which is 36. And the square root of 2 times the square root of 2 is the square root of 4, which is really just 2. So I have 36 times 2, which is 72. So essentially what I'm doing is I'm squaring the 6 and I'm squaring the square root of 2. Remember, when I square a square root, the square and the square root symbol cancel out and I'm just left with the number underneath. So that's what happened here with our square root of 2's. And then we had 6 times 6, which is 6 squared. Okay, let's go back to our problem here. So I'm now going to work this out where we have 6 squared is 36 plus x squared equals, now from what we got on the other page, square the 6, 6 squared is 36. Square root of 2 squared is going to be 2. So 36 times 2 is 72. Alright, now I'm going to subtract 36 from both sides. So I now get x squared equals 36. Remember, to undo a squared, you square root, so x equals 6. On example 3, we look at this picture and we need to be able to figure out where the right triangle is that we're going to have to use. In some of these pictures, it may not give you just a right triangle because you've done that in previous classes. So you need to be able to pick out those figures. For example, we can draw this line right here, which makes this a right angle. So I now have this right triangle that I can do Pythagorean Theorem with. So I see that I now have these two legs, here and here, and I'm solving for my hypotenuse. Now what I've created is I've created this rectangle here with 5 and 8, and I'm going to use those to give me the lengths of my triangle. So I know this side has to be 8 because of the rectangle. I know across from the 5 here, this little piece is also 5. And so I know the whole base is 11 minus 5 gives me 6. Now I have enough information to do Pythagorean Theorem. So I now have my a squared plus b squared equals c squared, where 8 will be my a, 6 is b, and x is c. 8 squared is 64, 6 squared is 36, x squared just stays x squared. Now 64 plus 36 is 100. Didn't do anything with x squared again. Now remember, to undo a square, you have to square root both sides. Square root of x squared is x. Square root of 100 is 10. Now where we're going with this later on in the unit and later on in the year is we'll then be starting to ask about area and perimeter and things like that. So being able to pick out these right triangles and help them and use them to solve is going to help you later on in the year. Alright, let's look at example 4. Again, we want to find the value of x. Looking at this picture, you need to be able to identify that this is a square. Now the reason I know this is a square is because we have these little dash marks on the sides that mean all of these are congruent. We also know this is a square because squares have all right angles. So I know we have all right angles, all sides are congruent, so I know this is x, I know this is x, and I know this is x. You need to be able to see that there's a right triangle made with the diagonal and then the sides of the square. I'll fill this in a little bit. Okay, so looking at that right triangle, I'm now going to use that to solve for x. Now remember, this is a squared plus b squared equals c squared. Here my a and b are the sides of the square. Well, one of the sides is x, so we square it. The other side of the triangle is also x, and we square it. And then our c is 5 square roots of 2 squared. Notice here I have x squared plus x squared. That's just 2x squared. Now remember how to square 5 root 2. You're going to square the 5, which is 25. Square root of 2 squared is 2, so 25 times 2 gives you 50. Now divide by 2. So I have x squared equals 25. Square root both sides, and x equals 5, which means all of the sides of the square are 5. From this, you might be asked what is the area, what would be the perimeter, or you might be asked further questions. All right, example 5. Find the length of the diagonal of a rectangle with a length 8 and a width 4. So first you need to draw your picture. So we have a length of 8, a width of 4, and I need a diagonal. Now, because it's a rectangle, I know my angles are going to be all right angles. So I know I'm going to use Pythagorean Theorem to solve for the length of that diagonal. Okay, the sides of my rectangle are going to be a and b, and I'm going to be solving for the hypotenuse here. So I have a squared plus b squared equals c squared. My a and b, 4 squared plus 8 squared, and we'll let our hypotenuse be our x squared. 4 squared is 16, 8 squared is 64, equals x squared. 16 plus 64 is 80. Now square root, so x equals the square root of 80. Now when we have the square root of 80, we have to make sure that we can't simplify that. So what I want to do, so I'm going to come over to the side and we're going to simplify the square root of 80. 80 is not a perfect square, so I have to use my factor tree. So 1 times 80, 2 times 40, it's not divisible by 3, 4 times 20, 5 times 16, not divisible by 6, 7, 8 times 10, and that's it. Now you need to notice that we have 5 times 16 and 4 times 20. We want to pick the highest that is a square. So we have 16 and 4. The highest of the two is 16. So we know those are the ones that we use to simplify. So I have 5 times 16 under my square root. 16 is the good guy because he's the perfect square, so we take the square root of it. Square root of 16 is 4, and we leave the 5. So we have 4 root 5. So that is what my final answer will be. Now, if on a homework or a quiz or a test and you left it as the square root of 80, it's not completely wrong, but it's the exact same thing as if you didn't reduce a fraction. You want to simplify your answer as completely as possible. So this right here is your final answer. But the square root of 80 is what we got. So make sure you're simplifying is all I'm saying. Alright, next. Find the length of the diagonal of a square with a perimeter of 24. Well, first of all, they said it was a square. So we know that all of our sides are going to be congruent. So if all our sides are the same, let's call them A. So we know all of our sides are A. So I know all of those added together have to be 24. So if they're the same, I know 4 times A equals 24. So my sides have to be 6 because we just divide by 4 on each side. So now that I know that my side lengths are all 6, I can now find the length of that diagonal. Now there are two diagonals, the one falling like this or the one going across like this. It doesn't matter which one you draw because they'll end up being the same length. So now you'll notice here, because in a square there are all right angles, these are right angles here. So I'm solving for my hypotenuse in that right triangle, which we'll let be x. And the sides are my A and B. So I have 6 squared plus 6 squared equals x squared. 6 squared is 36, so 36 plus 36 equals x squared. So I have 72 equals x squared. Now square root. So x equals the square root of 72. Make sure that 72 is simplified. So square root of 72. 72 is not a perfect square. So I have to get my factors. 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. So you'll notice here we have several different perfect squares. I have 2 times 36, 4 times 18, and 8 times 9. Remember, I want to choose the one with the highest perfect square in there, so I look at my perfect squares. I know I want to choose 2 and 36 because 36 is the largest perfect square that's a factor. So 2 times 36 goes in the square root. 36 is the good guy since he's the perfect square. Square root of 36 is 2. Square root of 36 is 6, and then we're left with the 2 inside. So I now know my final answer is 6 square roots of 2. Alright, in example 7, we want to find the value of x in the isosceles trapezoid shown below. All that means is that these two sides are the same, which it shows us with the tens. Now you might say, well wait, I have some right triangles here. I have the right triangle created on this side. Then I also have the right triangle created on this side. Notice that I have an 8 and a 10 on each of them, and they're right triangles. Well, we know that those are congruent by our HL theorem when we talked about triangle congruence. So I know these two triangles are the same, so when I solve for these pieces here and here, I know they're going to be equal. So I'm going to use Pythagorean theorem to solve for those smaller pieces right here. So I know I have A, B, and C. So I have A squared plus 8 squared equals 10 squared. A squared is just A squared. 8 squared is 64, and 10 squared is 100. Subtract 64 from both sides, and A squared equals 36. Square root both sides, so A equals 6. So that means this piece is 6. So that must mean that this piece is 6. So now I just need this piece in the middle to be able to solve for that entire length that's x. Well, notice I have a rectangle in the middle where this base here is 10, so that must mean this piece is 10. Well, then I can just add all of my pieces for that base together. So I have 6 plus 10 is 6 plus 6 is 12 plus 10 is 22. So x equals 22. So like I said, we may have to use our right triangles as a step to get to what our final answer should be. So practice Pythagorean theorem on the homework.